Welcome to Modern Retrogramming with Plasma. This is episode 6, Statements and Expressions. Plasma statements look very much like other computer languages. They are composed of control flow, variables, functions, mathematical and logical operations. Control flow commands will be covered in the next episode. This episode will present the expressions used to calculate and test values. Expressions are evaluated as a sequence of values and operators. Operators can be unary, binary, and ternary. Values come from constants, variables in memory, and function definitions. Assignment is one of the simplest statements. We have seen Plasma can assign values to byte or character, or word or variables. This is just a simple little test showing that, Plasma can just assign stuff to variables. Print out the values, sure enough. Now let's look at the algebraic operators. The unary operator is negation. So we'll just negate A. Let's also use the binary algebraic operations and then print it out. So let's do some quick editing here. Duplicate the put integer statement so that we can print out our values as we execute them. Little cut and paste with the Plasma editor here. Okay, so let's use some sort of arbitrary algebraic expression here for B, showing that the order of operations are just like your standard algebraic order of operations. We'll quick compile this here. Now you may notice that we're using the 2.0 version, the developer preview of Plasma. The language hasn't changed, the language definition itself, but everything under the covers has, and it runs quite a bit faster. So here you see the results of those expressions. Nothing too exciting here, but just, again, what you would expect. Let's go back, edit our code, and we'll look at some of the logic operations. Logic uses the values of true and false. The logical unary operator is not. And it does just exactly what you think. It changes the value of true or false into the other false or true. We can combine these and say, let's say A is greater than 10 and A times 2 is less than 30. And that will use the logical value of true or false for that expression and set it to B. So when we go to execute it, we'll see that, okay, slight drum roll here, that the values of true when printed out as an integer show as -1, and the value of false is shown as a 0. And that has to do with making all the bits in the value 1 so that we can combine logic and the bitwise operators, which we'll get to here just in a second. So -1 is true. Now when they're evaluated in additional statements, say that we're looking at a testing expression, anything that's non-zero will be treated as true, and 0 is always treated as false. We go to our bitwise operators. This operates on each bit in the 16-bit value. So we'll use hexadecimal to make it easier to see how the value is affected by the bitwise operators. The unary operator is complement, and that just flips the value of each bit in the value. Now the other binary operators that we have available to us are AND, And these will all look very similar if you're a C programmer. These are the same operators used in the C programming language. So we have and, or, and exclusive or. And then we will print out how those bit values are affected by each of the operators. Let's go ahead and print out the values in hex instead of integers so it'll make a little more sense. So the underpinnings of Plasma have changed. Oh, let's try not to compile the actual binary. Let's try compiling the source code. There we go. The underpinnings have changed and is now quite a bit faster, in some cases more than 2x faster, but still runs just the same. So now we can see the effect of using those binary operators on those values. Now there's one more operator that those of you that are C programmers would be familiar with. Is called the ternary operator. Now a ternary operator is kind of like a logical test. It will evaluate to one or another value depending on if the logical term is true or false. What we'll do is we'll use a value of 12. And then we'll write this ternary operator, which uses, in C, you would have just one question mark. We use two question marks in Plasma to denote the logical test, and then a double colon to separate the two values that would be used, whether it was true would be the first one and false would be the second one. So if it's true, in this case, if a is greater than 15, we'll return 15. If it's not, we'll just turn the value of a. So this is a clamping operation. If we want to do, clamping of a value to a certain, range. We can quickly compile this. We'll run it and see that we return the value of 12. Okay, because 12 is obviously not less than 15. Let's change it so that we have a value that maybe is a bit bigger than 15. Now what do we get? Now Plasma can use also function definitions as values. And there we go. We see that even though a is 22, b is now set to 15. So it's always clamped. One of the more interesting features of Plasma is the ability to have multiple assignment. Now what this means is we've seen where we just assign one value to one variable. If instead, well, let me show you, this is what you would kind of seen up until now. We just do a simple little assignment. But Plasma allows you to sort of combine assignments. So it can look like this. You ask, well, that doesn't particularly look all that useful. But let's go ahead and show you that it just does exactly what it claims it does. And I'll show you a couple interesting things you can do with that. Yep, sure, 4 and 7, that's exactly what we expected. Here's some fun things you can do with it, though. What if we wanted to swap two variables around? In most languages, you have to either use some sort of a clever expression or a temporary variable to hold one of the values as you set the other one. With multiple assignment, we can just swap those variable names around and easily swap their values. Now that's pretty cool, but one of the really powerful things in Plasma is that our functions can also return multiple values. In this case, there's a built-in library routine called divmod, which will combine a division and a modulo operator all together. It's kind of an expensive operation to do on a poor little 8-bit 6502. And oftentimes you want not only the result of the division, but the remainder as well. So this little library routine only does the division once, but it returns both the result and the remainder. So our 7 divided by 4 gives us 1 remainder 3. So there you go. Value of multiple assignment. So that's just kind of a brief introduction to our expressions. I hope you like them.